Окей, yes. Доброе утро, друзья. Просто мой по-русски не хорошо, so I will be doing this in English, but I am working on it. I'm learning. I am Charles Nutter, Charlie Nutter to my friends. I'm going to talk a little bit about JRuby, how it's designed, how we're trying to optimize Ruby on top of the JVM, and hopefully what you all may be able to get out of it if you wanted to make a move to JRuby. Here's my basic information. Feel free to drop me an email, follow me on Twitter, whatever. I am a JVM language guy at Red Hat. I work in kind of a research prototyping group. I've been a JVM guy for over 20 years now, and working for 12 years full-time on JRuby. So we've put a lot of work into this project to try and make the best possible JVM Ruby for all of you. And this is my third time back to Moscow. I love coming here. I hope I can come back again. First of all, thank you very much. Red Hat has sponsored our work for the past 6 years, so buy something from Red Hat. Okay, let's talk about JRuby. So what is JRuby? Well, first of all, we like to say that JRuby is just a Ruby. It's a Ruby implementation. Don't need to think about it as being something related to Java. We write Java, so you don't have to. We are compatible with the current version of Ruby, Ruby 2.5. Now that 2.6 is settling, we'll start to work on that as well. Pretty much all the pure Ruby gems that are out there, we expect to work. If you run into a pure Ruby gem that's not a C extension, that doesn't work properly on JRuby, please let us know. We usually assume it's our fault first, and you should as well. We'll get it fixed. We'll make sure that it runs the way it's supposed to. If it works on CRuby, MRI, it should work on JRuby. So we try to be Ruby first, but we also are a JVM language with the power of the whole platform available to us. So what does that mean? Well, unlike Aaron, I am not a guy who wants to hack on GC stuff. That is not the sort of work I'm very good at. So one of the big things we get is all of the cool tooling and GC stuff on the JVM. This is a view of a tool called Visual VM for the JVM. And on the left, we can see we've got CPU usage monitoring. We've got the size of the heap. On the right side, we have a live view of the actual garbage collector in the JVM, showing allocations, showing as objects are getting promoted and cleaned up. So all sorts of tools, and this is just one of dozens, maybe hundreds of tools out there for monitoring the JVM. And they all work great with Ruby applications on JRuby. Of course, the JVM has real parallel threads, so we can actually use all the cores. This is just one JRuby process using all the cores on my system. So however big a machine you have, you can start up a single JRuby and take advantage of the entire system. It's a huge advantage for large applications. There's also a lot of fun things you can do on the JVM. Of course, Minecraft has a Java version from the classics here. This is a plugin framework written for Minecraft so that you can write plugins in Ruby. And this one basically just changes the number of chickens that hatch whenever you throw an egg. So 120 chickens will pop out. My partner on JRuby worked on this. He actually tested this out in one of his worlds where he had been building things very carefully and ended up creating so many chickens he had to reset the world and lost a whole bunch of work. But a lot of fun to play with, and these are the sort of things that we get out of the platform. And as I mentioned, of course, JRuby is a Ruby implementation. The current version, JRuby 9.2, is compatible with Ruby 2.5. We will do work on JRuby 9.3 to support updates to the 2.6 APIs soon. We always focus on trying to be as compatible and as similar an experience to CRuby as possible. You use the same tools, Ruby gems, Puma, Bundler, all of the same things run just like they do on CRuby if you use them on JRuby. Then after that, we work on performance. We like to have it run well, ideally run as fast as it should on the JVM. So I've mentioned JRuby 9.2. Of course, we've got Ruby 2.5 support with all the APIs that come along. We also did a bunch of work on better support for non-ASCII identifiers. So if, for example, you were writing method names in Russian, they would work a little bit better on 9.2. We fixed a bunch of errors with it. We also did some optimizations to keyword arguments, so they use less memory, they're much better performance, and then we're kind of preparing JRuby for some next generation optimizations I'll talk about later. So how do we do this, supporting these different Ruby versions? Well, we basically use CRuby's news file, where they track all of the new features for a given Ruby version. And we turn it into a checklist, and that becomes our checklist on GitHub, where we just go down the list and make sure all the features are there and available. We update our local copy of CRuby's tests. We run all of the same tests that MRI does, both the Ruby spec tests and the standard test unit suite that's in CRuby. And then we continue on from there and make sure everything's passing to a reasonable limit. Sometimes there's MRI-specific behaviors we don't implement. But here's basically what our checklist looks like. We just go right down the news file, check things off, and we welcome any contributions. So this is a very easy way for someone to get involved. Once we create our Ruby 2.6 checklist, anyone here can come in, take a look at that list, and if there's something you think you can implement in Ruby, like a new string method or a new array method, go for it. We're happy to incorporate it into JRuby with just a pure Ruby implementation. Maybe later on for performance we might do a more native version, a Java version, but it's very easy for everyone to get involved and help us keep up with the rapid pace of Ruby development. We do have an IRC channel on Freenode called JRuby, unsurprisingly. We have a Gitter for JRuby, and we're all available on Twitter. So if you want to find us, get some help getting into JRuby, we try to be very helpful and help people start working on JRuby right away. So we also do run all of the same standard libraries, and Rails, Rake, Ruby Gems, all of the pure Ruby stuff out there is expected to work. And so we run their test suites too. I'll show a little bit later what we have as far as Rails test passing numbers, but it's 99.9% of tests are passing. Small behavioral differences in the tests that sometimes don't quite match up. But Rails is one of the biggest targets. It exercises so much of Ruby, potentially more of Ruby than CRuby's own tests, that we try to use that as one of our sanity tests, our checks for programming and checks for compatibility. So I mentioned that I'm going to talk more about performance. This is where we'll have a little bit more of the bulk of our talk. So first of all, we'll talk a little bit about how JRuby's designed, what the architecture of JRuby is. So JRuby is what's known as a mixed mode runtime. And that basically means that we do have an interpreter, a bytecode interpreter basically, the same as CRuby. And so that runs for a while. It lets us get up and running quickly. But as it runs, we can gather information about that code. We can learn what methods are especially heavily hit, hot code. We can learn how best to optimize that code. And then later on, just in time for it to be executed fast, we compile it down to JVM bytecode. And then the JVM eventually takes that and it runs its own JIT and its own profiling and optimization, and it gets it down to native code. And in fact, JRuby was actually the very first native JIT for Ruby, just because we could lean on the JVM to do all that heavy work for us. This doesn't mean we were heavily dependent on the JVM to optimize well, but hopefully, as I'll show later here, you'll see the JVM is really doing an excellent job of optimizing Ruby code as it comes out of JRuby. Here's a bit more visual representation of this. So up at the top, we have JRuby's two modes for the mixed mode runtime, our interpreter that eventually spills over into the bytecode JIT. And then the JVM has very similar sort of optimization tiers. In the standard OpenJDK, there is a bytecode interpreter, there is a quick native compiler, and then there is an optimizing native compiler. And eventually, all of the Ruby code that we JIT should turn into fast, optimized native code and run directly on the CPU. And you can turn on flags on the JVM and actually watch the Ruby code as it becomes assembly code, if you like that sort of thing. So I've got a few micro-benchmarks here. Some of these are very small, silly benchmarks, but also including some Rails stuff, so real-world, actual application-level benchmarks. These are all very fun. Some of these are kind of useless, like unless you're running a company that's going to be generating Mandelbrot fractals, maybe this is not what you want to use JRuby for, but it's good for us to measure how we're improving over time, whether numeric algorithms are working well enough, whether things are optimizing right. It also lets us isolate specific areas of Ruby. So we may have a benchmark that just does keyword arguments over and over and over again. And then we can see what we're not optimizing for keyword arguments, presumably apply that to the whole application, and everything runs better as a result. So the first one, which is kind of a silly benchmark, it's a small micro-benchmark for our purposes, is just testing calls to the array bracket operator, the aref operator in Ruby. In JRuby 9.2, we did some work to improve the overhead here. One of the reasons that this is a little slower than it should be is because there's another bracket operator on string. And that bracket operator might potentially do regular expression matches, might update these special $tilde variables. And so if we see anyone doing a bracket call, we need to get ready. We need to prepare space for that possible regular expression match. In JRuby 9.1, we would just back off and always allocate that space whenever you see that particular method call. But in 9.2 now, we can just say, okay, well, they might just need the regular expression thing. We'll only have a small space in memory where we'll reserve a location for it, and it ends up speeding things up quite a bit. So here's our benchmark. We're passing in an array, accessing the 0th element of it, the first element here. And then we will do some warm-up and run through and see what our performance is. So let's see how this is looking in JRuby 9.1 versus 9.2. So here's our baseline, 9.1, getting roughly 30 iterations per second through this benchmark. With this little optimization that reduces the size of the frame, this reduces the size of the space to hold that special variable, we're getting closer to 40 iterations per second. So there, that's a small improvement on a very specific case, but these are the sort of little pieces that make up good performance for a large application. So we do little bits and pieces like this. We also leverage JVM features. So in Java 7, about 8 years ago or so, a new feature came along called Invoke Dynamic. The JVM has several bytecodes for doing method calls: invoke static, invoke virtual, invoke interface. But none of them really fit a dynamic language doing a dynamic call. So back then, we worked with Sun Microsystems, and then later Oracle, on creating a new bytecode for the JVM, specifically to help dynamic languages optimize dynamic calls. Like I said, this was added in Java 7. Over the years, it has steadily improved in performance. They've been getting better and better at optimizing this. And now in Java 8 and higher, they actually use Invoke Dynamic to implement Java features, which means they will continue to make Java faster with Invoke Dynamic, and we will get the benefits of that. Another powerful aspect of being on this platform is that we can just say, you guys can make this fast, and we'll get the benefits from it. So that's pretty great. Currently, there's a special flag to turn this on. You pass the JRuby-x compile.InvokeDynamic, mainly because there is a small startup hit. It's slightly slower than our normal startup because of some extra dynamic logic in the JVM, but this may be default soon. The current newest JVMs don't have this startup hit, and it's not as bad. All right, so let's go back to our little bench aref. We've got our baseline here with JDK 10. I believe JDK 11 was just released, but we'll show JDK 10 for the moment. So there's our baseline. If we throw Invoke Dynamic at this, now the JVM can see that these dynamic calls can be optimized. It can inline them and do the same sort of optimizations it does for Java. Now we're starting to get significantly better performance just by flipping this switch and using a JVM feature designed for dynamic languages. Okay, so then we can push beyond this. There are many different JVMs and many different JVM JIT compilers. One of the more interesting ones these days is called Graul. It's a new JVM JIT. It's written in Java itself. And that's interesting for hacking purposes, but it also has a number of more advanced optimizations than the standard JVM JIT that we get in OpenJDK. So this is available as of JDK 9+. I believe if you download JDK 11, it is now a standard supported part of the JVM, and you can flip another switch, I'll show a little bit later, to turn on the Graul JIT with your Ruby code and see what kind of boost you get. Now this kind of gives it away, the scale of the graph here. But we've got our baseline for JDK 10. We've got our JDK 10 with Invoke Dynamic. Now we throw Graul at this. We're really starting to see the benefits of this optimization. Now we're starting to get close to static language performance on a lot of these benchmarks. That's really exciting. So let me show one that's even more impressive. I mentioned numeric algorithms. Now, how many people are generating fractals on a daily basis? Probably not a lot of you. But somewhere in your system, there's probably some simple numeric algorithms or search algorithms or logic that could be optimized better if we can run numbers fast, if we can do arithmetic fast. So this is going to be a Mandelbrot example, not particularly useful for you, but it shows how numeric algorithms are getting better over time on JRuby. One of the main reasons that this is difficult for us, because we're on the JVM, and the JVM has objects, and we're dynamic, all of our numbers, fixed nums and floats, and I guess they're all integer now, they all end up creating an object every time. So what we need is for the JVM to see that the object itself is not necessary. All we really need is the numeric value, and then it can get rid of the objects if we don't need them. That's what we're starting to get out of Graul now. So here's our benchmark, just a kind of typical numeric algorithm, lots of floating point math and whatnot. And then down at the bottom, we do a little bit of warm-up, and then we're just going to time how long it takes to generate a 2,000 by 2,000 Mandelbrot fractal. Okay. Now this one I'm really excited about. So what does this look like when we start getting into the full combination of JRuby, Invoke Dynamic, this new Graul JIT, and hopefully other JVM JITs will start to follow suit soon. So we have CRuby 2.5 that takes about 3.5 seconds to run this benchmark. Now, for whatever reason, the JIT in CRuby 2.6 is still a little young. There's still some work to do. It only helps this benchmark very slightly. I would have thought that a numeric algorithm would get a little bit more out of the JIT. I'm sure that's going to come along as well. So don't take this as anything forward-looking as far as the 2.6 JIT. It's still a work in progress. Then we take JRuby, and now we've got a decent boost. In CRuby, they actually don't have to allocate objects for all these numbers. So the fact that we're able to beat them a little bit is actually pretty good. We are creating tons more objects, much more allocation, but still actually running a bit faster because the JVM optimizes so well. If we throw Invoke Dynamic at this, now we're starting to get a little bit more out of the JVM. Now we can actually start to see that if the JVM optimizes Ruby code the right way, these objects might not be as much of a problem. And now I mentioned that Graul has a bunch of new optimizations. One of those optimizations is called partial escape analysis. And so what this means is if we allocate an integer object, we use it in an algorithm, and then we throw it away, well, Graul can get rid of the object. It doesn't need it. It knows all we care about is what's inside the object, and we can get things like this. This is now getting very close to native Java performance for a primitive numeric algorithm. That's amazing. And that's just by switching to a newer JVM, a newer JIT compiler. And we're going to see more and more of this happening over the next few years and try and take advantage of this as much as possible. So some of you might have heard of another Ruby implementation that's based on Graul called Truffle Ruby. The Truffle guys are doing some very interesting experimental work of pushing very hard on peak performance and some clever ways of running C extensions and so on. So I thought I'd run and see what sort of performance we have compared to Truffle Ruby on this particular benchmark, and we're about the same. So we're getting the benefit of the Graul JIT with just a plain old JVM language that runs on any platform, doesn't depend on just the Graul runtime. We're getting that kind of performance out of it. And so we're hoping to see a lot more of this as we go forward. Okay, so let's move on to something a bit more practical for you all, JRuby on Rails. So this has been a long journey for us. We first managed to actually route a full stack Rails request in about 2006. That was after about a year of really intensive work on JRuby. When I started working on the project, we could not run IRB, we could not run gems, we could not run rake. We had to get all of that stuff working to even get to the point of running Rails. And so this is really almost as long as Rails has existed. We've been trying to get this to run really well. These days there are thousands of companies that run JRuby on Rails. Many folks will eventually move to JRuby when they need to scale up. They need to make better use of CPU, better use of resources. We had a story from a JRuby user. They migrated a CRuby app to JRuby and reduced their EC2 costs from 35 extra larges, like you can imagine what that is per month, down to 10 mediums. So if you want to save money, JRuby is a great way to reduce your hosting costs. You get better use of the hardware, better use of the resources. So we continued to try and support JRuby on Rails, but around the time of doing JRuby 9, which we called JRuby 9000 as a code name, it's now over 9,000, so yeah. We had to go back. We took a step back to catch up on compatibility, and Rails fell behind for a little bit. So we didn't support Rails 5.0 for almost a year. 5.1 and 5.2 came a little faster, but we've had to kind of reboot the support of Rails and catch up a bit again. So the biggest part of this is ActiveRecord. ActiveRecord in Rails is really the only part that requires a native library, a native extension, to access MySQL, Postgres, and so on. So our version, we don't have the access to the native library. We use the standard Java database API, JDBC. And this actually has worked out pretty well for us over time. JDBC is a very solid API. It's well optimized. Mostly what ActiveRecord needs is just a way to run a query and get results. JDBC does that quite well. So last year, or maybe a year and a half ago, we rebooted how we were doing ActiveRecord. For a long time, we had been trying to support all Rails versions in our library, because we didn't know which version of ActiveRecord JDBC they'd be using, so there was checks in the code. Is it Rails 3.2? Is it Rails 4? Is it Rails 4.1? Is it Rails 5? And that was just way too much code to maintain. It was impossible to deal with. When we rebooted it, now it's one-to-one match. So we will support the same way that Rails ActiveRecord does, a single Rails version. Cut our code size down significantly. So an example of how much easier it has been for us to keep up now with Rails 5.1, 5.2, the old MySQL adapter was 1,600 some lines of custom Ruby code for JRuby that we had to keep maintaining and keep working across different Rails versions as we went forward. When we switched to this exact match adapter, so the 50.0 adapter corresponds to Rails 5.0, the 51 adapter corresponds to 5.1, it dropped down to 284 lines. So we cut out so much of this code. And the really exciting part is when we moved to support Rails 5.1 and 5.2, we've only had to change a couple lines of code. So we will now finally be able to keep up on a regular basis with Rails release versions, and there is a 52.1 adapter out even now that supports SQLite, PostgreSQL, and MySQL very well on Rails 5.2. Here is an example of what we actually had to change. This is all that changed for 5.1. We had to add 2 methods that were added to the ActiveRecord structure, and things just started to work. So we'll be able to keep up much more easily now. I mentioned that we run Rails tests. Here are some Rails tests. These are a little bit older, from Rails 5.1.6. And you can tell there's really not that many failures. There's a few little things in here, but we're talking about 4 nines passing at least. Most of the things that do not pass are minor items. Things like we have slightly different ways of doing dates and times, and so I don't think anyone is going to care about this level of accuracy on a date time. We will try and see if we can match as many of these as possible, but this is the sort of thing that doesn't pass right now. Not very important tests. Anything that's crucial to a Rails application should generally work. So this is unfortunate. You probably won't run into it though. Rails 5.2, pretty much the same sort of performance, pretty much the same sort of compatibility. For whatever reason, the Railties tests now use fork, which we don't support. So that's kind of a bummer. We need to work with the Rails guys and make sure that these tests continue to run on JRuby. So Rails 5.2 status. Tests are running largely like Rails 5.1, 99.9 something % passing. Scaffolded apps, full stack applications work great. And as I mentioned, we do have support for all of the 3 core databases in our ActiveRecord JDBC adapter. So performance is what we really want to know about. Compatibility shouldn't be a problem. If you have any issues with running JRuby on Rails, let us know. Again, it's probably our fault and we'll fix it. Let's move on to actually looking at JRuby on Rails performance though. So the first thing I want to look at is just the performance of ActiveRecord. As everybody who's done Rails knows, your application lives and dies by the performance of ActiveRecord. I mean, that's where almost all of the work ends up going. So this is the largest CPU consumer, definitely the largest garbage and GC influencer. So I've ran a few benchmarks of just some very basic create, read, updates, and so on. I didn't deal with the delete benchmark here. If you're having performance issues with delete, we can talk about that. And I'm just comparing JRuby 9.2 on JDK 10 with CRuby 2.5 here. So first off, full disclosure, create, we're roughly the same performance as CRuby. It's a little faster here, probably just some optimizations about how many objects they create. It's a minor difference that we'll address. We generally expect that JRuby should run anything pure Ruby faster than CRuby because, I mean, we have a JIT, you know, it should be compiling down to native. It should generally be faster. So there's probably something we're not doing right here, but this is the state of things at the moment. Everything else, though, generally faster than CRuby. Sometimes quite a bit faster here. 5,000 find operations per second versus 4,000 for CRuby here. We have our selects, again, a similar ratio of performance improvement just for ActiveRecord itself. And again, it's kind of back and forth on whether Graul helps us or not. It's still kind of a new technology. But here we even get a little bit of boost from the Graul compiler. Updates, for whatever reason, are extremely fast, significantly faster than doing it in CRuby. Again, Graul back down below here. So your methods will vary, or your results will vary. You just try out Graul and let us know what you see. So this is very exciting for us. This is actually the first time in the past 12 years of having Rails work on JRuby that we can convincingly say we can run ActiveRecord faster. And we're very excited to finally be able to say that. So what about the problem of scaling Rails? We know that ActiveRecord is going to run fast. Ideally, the rest of Rails should also have a similar ratio of performance. But you need to scale this stuff up. So this is a classic problem of building a larger and larger application, a larger and larger service on CRuby. We have no real parallel concurrent threads on CRuby, so you need to spin up multiple processes. Even with the copy on write features in CRuby, these processes inevitably will waste some space. They'll duplicate some runtime state, whether that's internals of Rails, whether that's late loading Ruby code from your application. There's always going to be some waste along the way. And then you just have all these extra processes that are brutalizing the CPU, hitting memory, blowing out CPU caches. Having all these different processes can really throw off the system and waste a lot of time and resources, which translates to wasted money. If you're running your applications this way, sometimes you're just not getting the best out of what you're spending on it. And so JRuby is really an excellent option for this. Multi-threaded, true parallel threads. You can have a single JRuby instance that uses all 8, 16, 32, 128 cores, whatever you've got in your system. We can make use of all of it in a single process, and that means less waste of resources, more savings, more money in your pocket at the end of the day. So how am I measuring Rails here? Well, we're just going to do a simple request per second thing. Just run through a typical full stack operation and see what kind of performance we get. So this is full stack. We have ActiveRecord in here. And then we have various configurations of CRuby versus JRuby. This was done against Rails 5.1. I would not expect Rails 5.2 to be particularly different. I was running on Postgres here. Should get similar results out of the other databases as well. We do some warm-up. One of the slightly tricky bits about JRuby is that because we interpret it first and then JIT, and then the JVM interprets and then it JITs, it takes a little bit longer for us to get up to full speed. So generally we recommend if you want full speed for your production release, you would do a little bit of warm-up of the application. It's kind of like loading in caches, making sure that all the data is there. Not too foreign for most of us that have done large applications. I wanted to test this on a real-world environment, so this is on a C4 extra large with 4 virtual CPUs, lots of memory. I don't think we even come close to using the memory, but we definitely burn through those CPUs. And you know, again, full disclosure, I'm not isolating the database like you probably would in a production setting, so this is all on the same server. So take that as it is. So here's our full stack scaffolded read. Indy here on JDK 8 and JDK 10, I wanted to show the more stable, the standard version of the JDK and the newer versions that are coming out now, faster. I mean, significantly faster than CRuby. I want to show the truth about the warm-up curves here. So you can see the 2 blue lines here are CRuby, and there is really no warm-up time because even with the JIT, it doesn't particularly optimize the Ruby code. The performance you get at the beginning is pretty much the performance you get at the end. JRuby, on the other hand, after 10,000, 20,000 requests, we start to catch up and then go well past CRuby on performance. So again, trying to be honest about this, JRuby runs on the JVM. The JVM is known to use more memory. For one big reason is that they have such an excellent garbage collector. They allocate much more space, give the objects and memory a lot more room to breathe. That ends up translating to a much larger overall process size. So generally, a JRuby instance is going to be about 10 times larger than the equivalent CRuby instance. But now, if you think about this, how many instances of CRuby do you typically have to run in production to handle all of your concurrent requests, all of your users? Well, if you cross that line and you're getting to like 8 CRubies, 10 CRubies, well, a single JRuby is now going to be equivalent, maybe even smaller. And if you want to continue going on from there, from 10 to 100-way concurrency or 1,000-way concurrency, well, you can do the math. JRuby's still going to need only that one instance to run your entire site, whereas CRuby is going to require you to spin up another C4 extra large and another C4 extra large just to be able to handle all of these requests. So for the first time this year, we're very excited we can say JRuby is the fastest way to run Rails applications. If you are looking for more performance out of Rails, it may be worth your effort. Talk to us about migrating over and we'll see if we can get you up and going on JRuby. So I'll wrap up here. You can get JRuby, you can just go download it from jruby.org. I would expect more of you would probably just do RVM install JRuby or use whatever Ruby switcher. They all should have JRuby available. The only requirement is that you've got a JVM on your system. We would still recommend OpenJDK 8. It's a little bit older now, but the newer JVMs have some quirks we're still trying to work through. But you run OpenJDK 8, you should have all the full compatibility and pretty much the same performance I showed here. I mentioned that there are a couple flags that you can pass. The Invoke Dynamic flag to turn on that level of optimization on the JVM. This will definitely be a faster straight line or peak performance, but it may be a little bit slower to warm up and start up. So you'll have to decide how that affects your application. There's another flag here. In order to reduce the cost of allocating all of those fixnum and integer objects, we have a separate cache. So if you're using the range of -256 to 256 as a fixnum, as an integer, we have those objects pre-allocated to avoid reallocating those very commonly used numbers all the time. But if you're running with Graul and it's trying to eliminate the objects, it gets kind of confused because we've got some objects that are being created new, we've got some objects coming out of this cache. This flag turns the cache off. You get the best performance out of Graul if you turn this on. And then first, I mentioned startup time is sometimes a problem for JRuby. We do start up a bit slower. This --dev flag will essentially reduce the amount of optimization we do in a developer setting, reduce the startup time for JRuby about half. So if you're running JRuby in a local development environment, I'd strongly recommend you throw this into the JRuby ops environment variable. So I mentioned that you have Graul now available in the more recent OpenJDK versions. These flags can turn it on. You'll have access to this later on. We will very likely add a simple flag, a single flag to the JRuby launcher, the JRuby executable that does this for you in the future. But for now, you can just download JDK 10 or 11, turn these flags on, and see what kind of performance you get out of it. You can also download something called the Graul VM. It's sort of like a JVM, but it depends heavily on Graul, and it runs a lot of Truffle stuff. But it's an easy way to just get a Graul that's already installed without any flags. So it's a commercial product, but you can check it out, and it might be another way to run stuff. Also, a little caveat here, if you're running on OpenJDK 9 and higher, these are the little quirks we're dealing with. They've locked down some internals of the JVM that we used to get better Ruby compatibility. If you see these warnings, don't really worry about them. They shouldn't affect the performance or the compatibility of your app, and we're going to get those fixed for JRuby 9.3 so that we run just as well on JDK 9 Plus as we do on JDK 8. Finally, I just want to thank all of the different companies out there that have used JRuby. We've been very happy to help people scale applications, put larger and larger applications in production. Some of these I'm really excited about, like BBC News. All the election results for everything that happens in the UK is actually a JRuby application, delivering all of those results. You can imagine how much load there is for all the people looking for election results. NASA here, I love this one. The Allen Telescope Array out in California, which is used for the SETI, Search for Extraterrestrial Life. So they got a bunch of radio telescopes that they point at different spots in space and try to listen to see if there's any aliens out there. That's actually orchestrated by JRuby. There's JRuby that's orchestrating the position of the telescopes and integrating the data and passing it off to other stuff. And obviously they use C or C++ or native things to do the raw data processing and to run the actual telescopes. But JRuby is helping to find extraterrestrial life. That's pretty awesome. Bunch of other ones on here. Of course, we helped get Square off the ground because they use JRuby. Even the GitHub Enterprise product used to be JRuby based. So we helped them launch that product. There are many folks out there using JRuby. It's very solid and stable. I hope you all get a chance to try it out. Let us know what you think and if you run into any issues. And that's all I have for today. Thank you very much. And I think we did real well, so we got time for questions here.
А можно на русском вопрос задать? Возможно перевести докладчику?
Yeah. Thank you. I can hear the translation. All right.
Да, спасибо большое за ваш доклад. Очень хорошая презентация JRuby. Я когда-то пробовал JRuby 9000, когда он только вышел, там презентовалось то, что вот бесшовный переход с оригинального Ruby. У меня была задача написать параллельный обработчик XML файлов, и я столкнулся с проблемой, что чтобы получить действительно хорошую производительность, мне надо было обращаться именно к Java объектам, их инстанцировать и с ними работать. То есть получалось, что я в принципе писал уже не столько на Ruby, сколько на Java. Скажите, вот сейчас уже этот, как сказать, появилось ли больше нативного именно Ruby в JRuby, то есть чтобы получить тот же уровень перформанса?
Okay, so I think the question is basically when you've used JRuby in the past, you had to move to JVM libraries or Java objects to get really good performance out of it. Well, as seen here, I think we're starting to see the JVM really is picking up and optimizing Ruby code much better, much closer to Java code. So this will continue, but this is also part of a power of running with JRuby. You can use JVM libraries and Java objects, and they work very well together. I'd love to see what specific cases you had that were not running as well. Anything that you feel like you have to go from Ruby to writing in Java, that's an opportunity for us to fix. We'd love to know about it. And I think we'll continue to improve over time.
Спасибо. Ну, я на самом деле копировал со Stack Overflow, то есть ничего своего. Спасибо.
Maybe we'll start to pay more attention to Stack Overflow as well. Other questions?
Hello, Charles, thank you for your great talk.
Wave your hands. Oh, I see you in the back.
I'm here. Yeah. And I have two practical questions. The first one is all of our Rails web developers use some kind of background processing job tools. And the most popular nowadays, as I can see, is Sidekick. What do you recommend to use on JRuby instead of Sidekick in order to use JVM platform features the most?
I missed the middle part. Your developers are using what?
What kind of tools, do we have to use on the JVM platform instead of Sidekick, for example?
Okay. Well, you can certainly use Sidekick. Sidekick works great on JRuby, actually. Mike he's done talks and shown that JRuby with Sidekick it might actually be the best way to run Sidekick because of the parallel threads, because it actually can run these jobs in parallel. So at least for Sidekick, it should be good. Whenever there's not a tool like that, there's going to be something equivalent on the JVM. There's different drivers for NoSQL databases, there's in-memory databases, caching and message queues, and you can just call right into those. As I showed on the slide here, you can call any Java library, any Java object as if it was just a Ruby object. So if there's a Ruby tool out there, it's a very good chance it will still work just fine on JRuby, but you also have the options on the JVM too.
Yep, thank you. And the last small question. It's about the TalkBox. Do you know this project is the app server for the JRuby? As you can see, the latest stable version is still 3.2 and for many, many years. And I am still waiting for a 4.0 version, but it's still in beta. What do you know about the development of this project?
Yeah, TorqueBox, it's kind of a sad story. For folks that are not familiar with it, TorqueBox is basically they took a Java enterprise server, broke it up into pieces, and wrapped each piece with a nice little JRuby API. So you could get all of the enterprise messaging features, database features, all of that stuff with just a regular old Ruby application. It's really cool, it really is nice, and unfortunately the developers that were working on it at Red Hat have been pulled off to other things. So the only way that TorqueBox would move forward is if we can find some folks from the community to help finish it up and support it. At the moment, I don't know who that would be. But I really love the project. I wish that it could keep going. We just didn't have resources to keep working on it at Red Hat. All right, спасибо.
Hi, Charles. Thank you for the great presentation, and thank you for answering my questions by email. I mean, the interview. And you can read it actually in internet. And the question is, you showed the synthetic tests, and it seemed that Graul version is the fastest. It is faster than Invi version. But when we come to the Rails, it seems that Invi version is much faster than the Graul version. And Graul actually was even the CRuby version was faster than Graul version. And do you know why is it so, and which reasons? Maybe there are different like operations or different objects taking this performance.
Right. So I don't know exactly the reasons, but what I can say is that Graul is a very new, I mean it's not super new, but it's a new JIT. It's not evolving from the existing one. The existing JVM JIT has been around for almost 20 years now, and there's lots and lots of little optimizations, lots of real-world work to make it optimize stuff. What I suspect is that there's just some missing optimization, there's some feature from the old JIT that they haven't ported over to Graul, but we are working with the Graul team, with the Graul folks that work on that JIT to make sure that JRuby runs as well or better on Graul. So it should improve over time. I just suspect they're missing an optimization here and there.
But for now, it seems that the Invi version is the best. I mean, for use in production, right?
Right. Well, and even I mentioned that Graul is officially released and it is available in OpenJDK 11, but it's still an experimental flag. It's still being developed. I would still strongly recommend if you're going to run something in production, you use the standard JVM JIT with Invoke Dynamic. It's still kind of the best all-around performance.
Thank you.
All right.
Спасибо большое.
Спасибо большое. Charles, thank you.
All
very
right,
much.
thank you.